This is the capstone. Over 7 episodes, we built a real subword tokenizer from nothing. Today we finish the job. We package it into one clean module, train it on a real text file, and stream encode an entire corpus into a token array on disk. That array is the exact input the next course needs to start training a model. Let's ship it. Last episode we put our hand-built tokenizer next to the real ones, TikTok, Hugging Face, Sentence Piece, and saw there the same core algorithm, just larger and more tuned. Today we make ours production shaped. One module with 5 methods, a real training run, a tokenized dataset saved to disk, and a small benchmark so you know exactly how fast and how compact it is. Here's everything we'll do, end to end. A raw text file goes into train, which learns the merges. Those merges power encode, which turns the whole corpus into a list of token IDs. We save that list as a compact NumPy array, tokens.npy, and that file is what the next course feeds straight into a GPT. Save and load persist the tokenizer itself, and a benchmark measures compression and throughput. We start from the 2 helpers we wrote back in episode 2. Get_stats counts every adjacent pair of token IDs. Merge walks the list and replaces every occurrence of one chosen pair with a single new ID. These 2 functions are the entire heart of byte pair encoding, everything else is bookkeeping around them. Now the class. The base vocabulary is the 256 raw bytes, so nothing is ever out of vocabulary. That's the byte level idea from episode 4. Training repeatedly finds the most frequent pair, mints a new ID for it, and records both the merge and the bytes it stands for. We loop until we hit the target vocab size. That's the whole training algorithm in a dozen lines. Encode is the mirror image of training. We turn text into bytes, then keep applying whichever learned merge has the lowest index, the order they were learned, until no merge applies. Decode is even simpler. Look up each ID's bytes, join them, and decode as UTF-8. Encode then decode always returns the original text exactly. The round trip is lossless. To ship a tokenizer you only need to persist one thing, the ordered list of merges. We dump them to plain JSON. On load, we rebuild the 256-byte base and replay the merges in order, which reconstructs the entire vocabulary deterministically. No giant vocab file, no special format, just the merges, and everything else falls out. Step back and this is the whole public contract, 1 class, 5 methods. Train learns the merges. Encode and decode are the lossless two-way translator. Save and load make it portable. This is exactly the shape of every real tokenizer you'll ever use. Ours just has its insides fully visible to you. Now we use it for real. We read an actual text file, train a 512 token vocabulary on it, and save the result. Then, the important part, we create a fresh tokenizer, load the saved file, and assert that a full encode-decode round trip still works. That assert is your proof the saved artifact is correct and self-contained. And it runs. Look at the first merges the algorithm discovers entirely on its own, E space, S space, TH, IN, T space. Those are the most common pieces of English prose, word endings, and the start of the. Nobody told it that, it learned them from frequency alone. The save, reload, and round trip all pass. The tokenizer is shipped. Finally, we tokenize the whole dataset. We encode the entire corpus to a flat list of IDs, wrap it in a NumPy array of unsigned 16-bit integers. Our vocab is well under 65,000, so each token fits into bytes, and save it as tokens.npy. That single compact file is precisely what a model loads to start training. While we're here, we time it to measure compression and throughput. Here's the payoff. Almost 125,000 characters collapsed into just 27,400 tokens, a compression of about 4.5 characters per token, which is right in the range real English tokenizes hit. Our pure Python encoder pushed nearly 50,000 characters a second. And tokens.npy now sits on disk, ready to become a model's training set. Take a moment on how far you've come. You started by encoding single characters, then built byte pair encoding merge by merge. You went byte level so nothing is ever unknown, added special tokens and chat templates, understood how token IDs index an embedding table, compared against production tokenizes, and finally packaged your own and produced a real training dataset. Every line was yours. That's the whole course. You can now build, ship, and reason about tokenizes from first principles, and you have a real tokenized dataset to show for it. That tokens.npy file is the bridge to what comes next. In the follow-up courses we turn those token IDs into embedding vectors, and then build and train a GPT from scratch on the very file you just made. Thank you for building along. I'll see you in the next one.